Students, Sairam, this is Megha Miss here, and today we will continue with our lesson number 14, that is substances in common use. Okay student, this is our session 3. Now in the last session we studied about, if you remember, washing soda we saw, okay, bleaching powder we have studied. Yes students, then we have seen some of the crystalline salts. I told you alum and all, blue vitriol, green vitriol and all you saw, and I told you that you are going to learn it, the formula. Along with the formula you will learn it and keep. Okay, then we studied about these soaps, and we saw that yes, the bathing soaps and the washing soda or the washing soaps what we are using, they are totally different, right? And I told you can find out the difference between them, what is a bathing soap while what is a washing soap. Okay students, washing clothes, utensils, that type of a soap I am talking about. Okay, so now we will continue with the next part student. The topics which have been deleted from your portion for this year I have not included, so go through the presentation properly. Whichever part I am not teaching, that part you don't have for this year in your exam. Okay students, now the radioactive substances. Now the next part we are starting with, that is the radioactive substances student. Now the elements with a high atomic number such as uranium, thorium, radium have a property of spontaneously emitting invisible, highly penetrating and high energy radiations. Okay student, so which are those? They have the high atomic number. Examples you will remember students, that is the uranium, thorium, radium. These are some examples. Okay, and they have a property of spontaneously emitting invisible, okay, highly penetrating and high energy radiation. This property is called as radioactivity. Okay students, a substance having this property is called a radioactive substance. So can I say uranium is a radioactive substance? Yes. Can I say thorium is a radioactive substance? Yes, I can say. Okay, the nucleus of the radioactive elements is unstable. Okay, it is unstable. Radiation occurs from an unstable nucleus. Okay, there is no stability in this atoms of the radioactive elements. Radioactive substances are relevant to our day-to-day life. Three types of radiations are given out by radioactive substances. These are alpha, beta and gamma rays. Now this you must have, we have went through this in your 8th standard also. You have seen, yes, you have the three types of three types of radiations, and that are alpha, beta and gamma. Okay students, now nature of radioactive radiations. Now how are these? In 1889, Rutherford discovered that the radiations emitted by radium were of two types. Now you have studied about Rutherford in your previous standard also. Okay, they are called alpha and beta radiations. Willard discovered the third time, namely gamma radiation. So first Rutherford, he could find only two types of radiation student, that were alpha and beta. Then Willard came and he told about the third type of radiation, that is gamma radiation. When these rays are allowed to pass through two oppositely charged plates, they get separated. This method was introduced by Rutherford in 1902. Rutherford and Willard studied the radiations emitted by the radioactive substances. For this purpose, the rays were allowed to pass through an electrical field and a photographic plate was held in their path. Okay, it was found that the radiations was divided into three types. Okay, so they did some experiment together, Rutherford and Willard, and then they saw that there are three types of the radiations. Okay students, one type of radiation deviated slightly towards the negatively charged plate, while the second type of radiation deviated, means went substantially towards a positive charge plate. So electrical field is there, that means a positive and a negative terminal will be there, right? So some of the radiations, they found that they were deviating, they were going towards the negative charge plate, while some were getting deviated near to the positive charge plate. Okay students, however, the third type of radiation did not deviate at all in the electrical field. Means the third type of radiation, it did not show any type of deviation. Okay students, in the electrical field. The rays which deviated slightly towards negatively charged plate are called alpha rays. Those which deviate substantially towards the positively charged plate are called beta rays. And those which do not deviate at all are called gamma rays. Okay students, how you will distinguish between the three rays? The rays which deviated slightly towards negatively charged plate are called alpha rays. Those which deviate substantially towards the positively charged plate, they are called beta rays. And those which do not deviate at all, we call them as the gamma rays. Okay students. So, see, this is the alpha, beta and gamma rays. You can see a radioactive substances inside a lead box. Okay. A slit is kept in between and electrically charged plates are kept. Electrical field positive and a negative. And you can see a photographic plate, or you can say it is kept here. Okay. Zinc sulfide, it is written here, coated photographic plate. Okay. So you can see here positive, you got, see here alpha rays, beta rays, okay, and which do not deviate came straight where the gamma rays. Okay students, study the diagram also. Okay. Now characteristics of alpha, beta and gamma rays. Now you will see their characteristics. Now property, first we are going to see the nature. Alpha rays, current of alpha, He++ particles. Beta rays, current of beta, electron particles. And gamma rays, electromagnetic radiations. So they are electromagnetic radiations, current of beta particles, and this is current of alpha, He++ particles. Okay. Mass, if you see about the alpha rays, it is 4.0028 U. Beta rays 0.000548 U. Gamma rays no mass. Okay student. Charge, alpha rays, now you know, see here it is written He++. Okay, plus means what students? That is +2. So charge, you can see here it is +2. Beta rays, it is going to be -1. And gamma rays, they are electrically neutral. Okay students, I hope this is clear to you. Velocity 1/5 to 1/20 times the velocity of light. Beta rays 1/5 to 9/10 times the velocity of light. Here gamma rays same as the velocity of light. Okay, so all the speeds with which this alpha, beta and gamma rays travel, that is also compared. Okay. Now fifth one, deviation in the electrical field. Attracted towards negatively charged plate. Okay. Attracted towards positively charged plate, that are the beta one, right? And not deviated. Gamma rays do not deviate. Okay. Penetrating power, can penetrate an aluminium sheet of thickness, okay, that is 0.02 mm, okay, which is less than, you can say, 0.02 mm, okay. Can penetrate an aluminium sheet of thickness 2 millimeter, which is 100 times the penetration of alpha particles. Okay. Can penetrate 15 centimeter thick lead screen, which is 10,000 times the penetration of alpha particles. Okay students, so I hope that penetration power also you have understood. Okay. Next is the ionization power. Very high of the alpha particles, beta particles is low, gamma particles is very low. Power to produce fluorescence, you will see that alpha, it is very high, beta very low, and gamma low. Okay, so at least 4 points for the distinguish you are going to study from. Total 8 are there, at least 4 you will study. This question can come for distinguish, not all 3 together, but yes, I can ask any, no, any 2 combinations I can make and I can ask. Okay students, so properly you study this table. Okay. Now Uses of radioactive isotopes. It is a misconception that radioactive elements are used only for making an atom bombs. Okay, students? It is not like that radioactive isotopes, they are just used in making of the bombs and all. Okay, no, it is not like that. Okay, where we are using it? Radioactive isotopes are used in various fields such as scientific research, agriculture, industry, medicine, etc. So see, in medicine also you can use this radioactive isotopes. Okay. Radioactive substances are used in two ways. First way, by using the radiation alone. I can use the radiation alone. Okay. Or by using the radioactive element itself. So I can just use the radiation of that radioactive element, or I can use that radioactive element itself. Okay, students. So I hope whatever I have done till here you have understood. Okay. So should we proceed? Okay, student. Hazards of radioactive substances and radiations. Okay. Now before this, uses has been explained in detail. That box has been cancelled out for this year. Okay. So you don't have to study that box where the uses of the radioactive substances have been explained. Okay, in different fields, but you are not going to study that part. We'll directly study down a smaller box is given which is showing us about the hazards of radioactive substances and radiation that you are going to study. Okay, students. First one, the central nervous system is affected by radioactive radiations. Okay, student. So see, directly these radiations go and attack upon our central nervous system. Okay, so very dangerous. Okay, students. Hereditary defects are generated by bombardment of radiations on the DNA in the body. Okay, so hereditary defects can be there. Okay, student. Why? Because these radiations, they go and bombard to the DNA. Okay, in our body. Radioactive radiations can penetrate the skin and cause diseases like skin cancer, leukemia, etc. Okay, so if they penetrate in our skin, yes, it is going to be surely dangerous for us. The radioactive, that is the radiative pollutants created due to explosions, enter the body through the air and it is difficult to control them. Okay, like whenever there is some of the blast and all, that time what happens, that due to the explosions there are the pollutants, right? Whatever radiative material is used, okay, totally it is not getting decomposed, we can say. Okay, it remains as a garbage, right? So if that small particles enter in your body, students, it will be difficult for you to control them. Okay, it may cause you difficult type of illness. Okay, so it is these are some of the hazards of the radioactive substances and radiations. Okay, I hope all the 4 points are clear to you. You have to study all the 4 points. Okay, here only 4 points are there, half of mark each. Okay, the radio for this 7 points, 4 points, first 4 points are easy, you can study them. Okay, fifth one is the radioactive pollutants released in the sea enter the bodies of the fishes and through them enter the human body. Okay, so as I told you, pollutants, again because of the blast and all, whatever the trash or something is left over, that is your pollutant, right? Radioactive pollutant. So they enter into the sea. Through that sea water, it enters into the bodies of the fishes, and human beings, those are non-vegetarian, they eat such, if they eat such type of a fishes, pollutants will surely enter in their body. Okay, and they will fall ill. Sixth one, the radioactive paint on the watch can cause cancer. Okay, students, so if the radioactive paint is there on your watches, it can cause cancer. Okay, not in one day, but it will, if prolonged use of such watches, then it can cause you the damage. Okay, the radioactive isotope strontium-90 can enter the body through plants, fruits, flowers, cereals, milk, etc. and cause diseases like bone cancer, leukemia. So radioactive isotope like strontium 90, they can enter to your body through plants, fruits, okay. All the pesticides and fungicides what are spread, they may contain this strontium 90, okay. And if they enter in your body through any source, that is the plants or the fruits or the flowers or the cereals or the milk, etc., then they can cause you the diseases like bone cancer and leukemia. Okay students, so I hope what are the hazards of these radioactive elements you have understood. Okay, so today we have studied about, students, what you studied. Yes, we saw about the radioactive substances, uranium, thorium, radium. We saw 3 examples, okay. More are there, okay. Then you saw about the nature of radioactive radiations. Then you saw the uses of radioactive isotopes. Yes, you have seen. And then we have studied about the hazards of radioactive substances and the radiations. Okay students, as I told you, you are going to remember at least 4 points of each. You have seen alpha, beta and gamma radiations. They are distinguished. That table you are going to study. At least 4 points from that table you will learn by heart. Okay student, so I hope whatever we have done today you have understood. I'll stop it here for today. We'll continue with the lesson in the next presentation. Okay students, thank you. Sai Ram. Take care.